All right, chapter 16 is our last chapter in probability unit. That's part 4 of this course. And this one is about 2 specific types of probability models. There are 2 types of probability models that we will examine. They are called the geometric model and they are called the binomial model. Geometric and binomial. And really what these are certain situations where we ask you to find the probability that we kind of over and over again, it's the same type of scenario that we look at and examine a lot. And so we went ahead and gave them names, and one is called the geometric and one is called the binomial. And because they are very specific types of examples, we actually have the buttons in the calculator program to find these probabilities. So if you can recognize whether you're doing geometric or binomial, you can use buttons in your calculator to help you do these probabilities. We've actually done a couple of geometrics already, and we've done a few binomials, but this one's easier to see when you're doing geometric. It's also easier to calculate. Binomial is harder to calculate, which is by hand, which is why we haven't done too many of these so far. But you'll have more in this chapter as now you know how to do them in your calculator. Both deal with something called Bernoulli trials. Bernoulli was just an Italian mathematician, and he dealt a lot with these different types of scenarios. And so this is a certain type of situation named for the man who did a lot of work with them. So what are Bernoulli trials? Bernoulli trials have 3 requirements. 1, they have 2 possible outcomes. We call these success and failures. Now guys, there could be more than 2 outcomes, but when you're only interested in one, we call one of those outcomes, we call that a success, and we call everything else a failure. So for example, when we do get to the light, if it's red, green, or yellow, there's 3 outcomes. But I can consider in Bernoulli trials by thinking, well, I'm just interested in getting a green. So green is a success and not green is a failure. So you kind of clump all the others together. The probability of success, which we call P, is constant. It does not change. And also the trials are independent. So if you have these 3 requirements, then you are in fact talking about Bernoulli trials. And so a lot of things we've been doing have been Bernoulli trials, like flipping a coin, rolling a die. If you look at the number of ones, that could be considered a Bernoulli trial. Lots of different scenarios. All right, we're going to first talk about the geometric model. I mentioned this one before in class when we were doing the Chapter 13 skills check. You use the geometric model when you are examining when you are examining the number of trials until the first success. So this right here is how you know you're dealing with the geometric model. So you have to look for something in the words of the problem to kind of clue you in that this is a geometric model. So this is our no, 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 yes scenario. This is when you don't want the success, don't want the success, don't want the success, etc., and then yes, I got it. So on that first skills check, we had a question like, what's the probability that the first orange is not picked is not until the 5th pick? So you needed not orange, not orange, not orange, not orange, orange. That's called the geometric model, and you can use this model to find its answer. Now you did that problem without knowing everything that I'm about to go through with you, because you can do them without the calculator, but all the probabilities are programmed in your calculator, so you can use your calculator as well. So the name of the model is GeomP, and P is the parameter, or that's the probability of success. So whenever you go to use a geometric or a probability model, and you're going to use buttons on your calculator, you need to name it and tell me the parameter, which is going to be P. Now don't write the letter P, write what P is. Just like with the normal model, when you go to use a normal model, you always start off by naming which model you're going to be using. Same thing here. Start off by writing GeomP and then whatever P is. P is the probability of success. Q is the same thing as 1 minus P. In fact, your formula sheet has 1 minus P on it instead of Q. And it's the probability of failure. It's just everything else. And X is going to be the number of trials until the first success. So we have a couple of formulas we're going to write in here. This first formula is how you find the probability of the first success, that's capital X, being on a certain position. So like let's say X equals 4. That's the scenario here. That's where the first success is in the 4th spot. So no, 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 yes. And that is equal to Q to the X minus 1 times P. And that's the formula on the geometric model. Now this is what's programmed in your calculator. So you can either do this by hand or just type some buttons in your calculator. I'll show you that in a minute. All right, we also have a mean, an E of X, or an expected value, mu of X, average, same thing, and it's 1 over P. And we also have a standard deviation, or a sigma, and that is the square root of Q over P squared. So this is the formula to find the probability of X being in a certain position. This is the average, the mean of where you expect the first success to occur, and this would be the standard deviation of where you think that success would occur. So let's go through a for example. Suppose that 91% of your emails are spam. So if 91% of your emails are spam, then that means 9% of your emails are real messages. Assume that your email is typical and you're not using a spam filter. Also, since spam comes from many different sources, we're going to consider our messages to be independent. Remember, we can't use the geometric model if we don't think we have independence. Overnight, your inbox collects email. When you first check your email in the morning, about how many do you expect to have to wade through and discard before you find a real message? So be aware of what a success is. Sometimes the success is not always a good thing, but in this case, they're wanting to know how many emails do you need to go to until you get to a real. So real message is what like X is in this context. So we're going to let X be the position of the first real message. And because we believe we have independence and we have real or not real, and the probability of real is staying constant, this is a Bernoulli trial. And because X is the position of the first real, we are using a geometric model where P is 0.09, the probability of a real message. And they're just simply asking for this question, this question here, the mean. What's the average? What's the average number of trials until the first success? Or what's the average position of the first success? So this first question is to find E of X, or the mean of X. Whichever way you want to write that, it doesn't matter. And that is 1 over 0.09. That's 1 divided by 0.09. So if we go to our calculator and we type that in, we get about 11. So we would expect to have to go through about 11 messages before we get to our first reel. And if you kind of think about the numbers, 91% and 9%, that kind of makes sense. 91 out of 100 emails would be spam. So we expect a real message every 9% of the time. So we would need to go through about 11 messages until we got to that real one. If you think about that, that should make a little bit of sense to you. All right, what's the probability that the fourth message in your inbox is the first one that's real or isn't spam? What's the probability that the fourth one is the first real message? So we're still talking about this same model, the position of the first message, but I'm asking you to find the probability that X equals 4, that the position of it is 4. So what I'm asking for, that's this formula here. This is how you find the probability of that. And that's that no, 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 if you kind of think about positions, yes scenario. And this formula is telling me to do Q, or the probability of spam. That would be 0.91 to the third power x minus 1, x being 4, times the probability of success, 0.09. Now this should feel a little familiar to you. This is what we did in chapter 13 when we were first learning that we would multiply spam, 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 real. So 0.91, 0.91, 0.91, 0.09. That's what I'm doing here. So this formula is really not anything new to you, hopefully. It's just a matter of learning that we now have a name for this scenario, and also learning in the next video that we can do this scenario also in our calculator by just clicking the geometric button. 0.91 to the third power times 0.09 is 0.067. So the probability, or we'll go round it off, the probability of the first real one being in the fourth position is 0.068.